So if you're just joining us today, we just went ahead and did these problems for warm-up. We are spending the next couple days going back to last week and reviewing everything we've done into kind of gearing up for a quiz maybe Wednesday, Thursday, or Friday this week, depending on how well this week goes. We're looking at a quiz on everything that we've done last week. So we're going to do a lot of reviewing today. We're going to go back to terminal points today, and we're going to add in one term called a reference angle. Okay, so a little bit new, but a lot of old. So this will be Objective 13. We're going to find reference angles on the unit circle. Okay, so we're going to be talking terminal points. We're going to be drawing our angles again. I tried to put in some examples, some in degrees, some in radians. I tried to put in some that rotated more than one full rotation because those were the ones that you told me last week you were confused on. Everybody good? Everybody got their unit circle handy with them? So make sure you have your unit circle out with you because I'm going to ask you like where we're at on the unit circle. So here's the definition. When I ask for a reference angle, and it might be referred to as a reference number, okay? But if I'm talking about the reference angle, I'm talking about the shortest distance along the unit circle between the terminal point. What's the terminal point? Where you end after you rotate, and the x-axis. Does that make sense? While you're copying this down, I'll kind of just give you an example. So if I rotate, let's just say I rotate, and I start here, and I rotate around and around, and I end over here. What am I talking about? If the reference angle is the shortest distance from the terminal point to the x-axis, where would be the reference angle? Like, let's just say I stopped over here at 5 pi over 6. Let's say this is 5 pi over 6 over here. What's the shortest distance between this point and the x-axis? How much? Just that, like from here, where's the x-axis? Here, right? I want to know what's the distance from there to there. That's going to be your reference angle. So you might know that. I think it's just pi over 6. Because if this is 1 pi over 6, this would be 6 over 6. Everybody agree? 2 pi's over 6, that would be one full rotation. That would be 12 over 6. If I go all the way over here, how much pi's over 6 would it be? Another 6 pi's over 6. Well, I only I stopped at 5 pi over 6. So how much is left to get to the x-axis? Another pi over 6. Does that make sense? So in this case, pi over 6 would be the reference angle. It's the shortest distance between your stopping point and your x-axis. Okay? And it just depends. Like if I'm over here in the third quadrant, what's the shortest distance to the x-axis? Would I want to go to the right or would I want to just go up? Up. It's the distance from here to there. Okay, if I'm over here, what's the shortest distance to the x-axis? Right there. Does that make sense? If I'm in this quadrant, first quadrant, the shortest distance is going to be there, that way. Okay, and so I want to know how much that is, whether it's in degrees or in radians. That's what we're talking about today, the reference. Yes? Then it doesn't matter. If it's here or if it's here, how much is it going to be? How many degrees? Again, if we're at the 90, like, what's the reference angle if you're on the y-axis? How many degrees? It doesn't matter which direction you go. You could go that way or that way. It's 90 degrees. Does that make sense? Or if it's in radians, how many radians? Pi over 2. Does that make sense? So it doesn't matter if you're on the, you can go in either direction. Okay? All right, so let's look at some examples. So we're going to talk terminal points. The first thing you got to do is you got to draw it. That's going to be step 1. Step 2, you got to figure out your terminal point, where you're stopping at. Okay? And 3, then you can find your reference angle. Okay? So step 1, I want you to take a minute and I want you to draw this angle. So this one should be pretty easy. If I'm going to draw 5 pi over 6, where would I end at? So I'm going to start over here, and I'm just going to end over here at 5 pi over 6, right? So that's your terminal point. It's 5 pi over 6. Everybody understand that? That's your terminal point. If I want to know the reference angle by definition is the shortest distance to the x-axis. So the shortest distance to the x-axis is going to be, give me a color, it's going to be here. There's your reference angle. So how much would it be? We've already done this. Pi over 6. Does everybody understand why it would be 1 pi over 6? Because if I was counting by 6s, halfway around would be 6 over 6, right? So if I'm only going 5 over 6, then how many is left to get to the x-axis? 1 more pi over 6. Okay? So pi over 6, so this is going to be equal to pi over 6. That's your reference angle. Okay? Yes? So here's what I'm going to tell you. I would like for you as a rule, I would like for you, if I give it to you in radians, I'd like for you to give me the answer in radians. If I give it to you in degrees, I'd like for you to give me my answer in degrees. Okay? That's kind of a rule of thumb. Okay? I don't know that I would count it wrong, but I might take a point or 2 off because it's not given in what I gave it to you in the form. Okay? And we'll look at some, I've done mostly in radians. Why do I do most of them in the radians? Just because you're not as comfortable with radians as degrees. Does that make sense? So I want to make sure you can do these. I think the last time I taught this, I did a lot in degrees because that's the way my students liked it. They liked it in degrees. But then when I gave them a problem in radians, they couldn't do it. So I'm going to really hit radians pretty hard. All right. So my first thought to you is I want you to draw this. Appropriate. All right, so if I drew this, let's draw them in red. I'm going to start here. Where's 7 pi over 4? In quadrant number 4. Okay, so there's 7 pi over 4. And my reference angle is the shortest distance to the x-axis. So that's going to be from here to here. Okay, so you need to understand how to count. You know this would be 4 pi over 4, right? All the way around would be how much? 8 pi over 4 would be there. So my question is, how much further do I need to go? I need to get pi over 4. That's your reference angle. So the reference angle is going to be equal to pi over 4. Any questions about that so far? All right. Draw it first, find your terminal point, then find your reference angle. So where would 2 pi over 3 be? The second quadrant? Which way are we rotating? So what quadrant would it be in? The third quadrant. So it's going to be down here because you're rotating. Normal 2 pi over 3 is here, right? So if I'm going into a negative, I'm going the same distance from here to here, except I'm going to go in a negative direction. So there's your terminal point. So negative 2 pi over 3. So my question is, if I want to find the reference, what would it be? How many more do I have to go? Pi over 3. My question, is that going to be positive or is that going to be negative? Why positive? We're going to refer to all I'm asking for is what's the distance between here and here. So even though I'm traveling in a negative direction, does that make sense? The actual reference angle, if I want to know how much is this angle, does that make sense? How much is this angle right here? Everybody understand that? I'm going to refer to it as positive. So I need to go another pi over 3. Does everybody understand that? So this is going to be pi over 3. It's just always going to be positive because I'm not asking for you to continue rotating. I'm just saying, how big is this angle? Does that make sense? So that's your reference angle. Distance is always positive. Like if I travel, I'm traveling in a positive distance. Okay, so now let's get to the hard ones. All right. Let's go. Which way am I going to be rotating first? So I'm going to rotate counterclockwise. Let's start by counting half circles, and then we can get into counting whole circles. Okay? I always start by half circles, and then I kind of jump to whole circles. Okay? So this would be, how much first? All right, so this is 6 pi over 6. Then, and if I went all the way again, how much? 24. If you wanted to, you could go 24 and then just subtract 1. Or you could say you're at 18 here. How many more to get to 23? You need to go how many? 5 more. So I'm going to end here. Okay? So you need to know that this is 23 pi over 6. Okay? How many got it drawn correctly? Yay! So we're getting better at these. Yes? Good. All right, and then we're going to find our reference angle. So our reference angle is the shortest distance between where we stop and the x-axis. So how much more do I need to go? Another pi over 6. So that's going to be your reference angle. Any questions about that? All right. This is different. I gave it to you on purpose. Why is it different? Because, okay, so there's no 9 on the unit circle, right? But that's okay. I'm not really looking at the unit circle and their coordinates right now, correct? So there are other points on the unit circle besides what we have here, right? You can still count and find your reference. All I want to know is draw it and find your reference angle. So it's no big deal. What are you going to count by this time? 9s. So don't let that confuse you just because it's not on the unit circle. So I'll give you a couple minutes. All right. 35 pi over 9. So which way are we rotating? Counterclockwise. All right. So let's start counting. So how much do we have? How much do we have here? 9 pi over 9. If I keep going, then I have 18 pi over 9. If I keep going, I have 27 pi over 9. If I keep going all the way around, then I have, so you stop right before you get there. So this is going to give me 35 pi over 9 is right here. 35 pi over 9. So my question is, What's my reference angle right here? Pi over 9. It's not always going to be pi. It just happened. I made these up off the top of my head, and it just happened that that's what they ended up being. So what if it was 33 pi over 9? Then it would be 3 pi over 9 or just pi over 3. Does that make sense? You'd have to simplify it. So it's not always just going to be pi over whatever over the denominator. It just happened. That's just a big quinky dink. Okay? All right. Try that one. That's exactly by 9s. I think that's a good question. I think I actually did not, if I'm counting correctly, McKaylee, I think it's not going to be pi this time. Unless I didn't count correctly. Ah, darn it. Let's rotate. Which way are we going to rotate this time? We're going to rotate clockwise. Okay, so let's start counting. This will be 3 over 3. This will be 6 over 3. This will be 9 over 3. 12 over 3. 15 over 3. 18 over 3. Oh, it is going to be fun. 21 over 3, and then one more is going to be 22 pi over 3. Okay, so my question though, that's where we're rotating to. So where's my reference angle on this one? It's just from here back down. So it's just pi over 3. And even though I'm rotating in a negative direction, your reference angle, I'm just asking, like, what's the distance from the terminal point to the x-axis? So distance is always positive. Does that make sense? Any questions on that? All right. I think we're almost finished. Let's look at one in degrees, just because I do want to make sure that you are comfortable in degrees. How many are feeling more comfortable in your radians? Better? Okay. Okay, so we're going to rotate which way? Clockwise. So let's just start counting by degrees, okay? And we know we need to make it all the way to, don't get so lost into negative. Like, really, the only thing about the negative is what? That's just telling you which way to rotate. Does that make sense? So let's just start counting by 180 to 360. So we have how much? 180, 360. If I go all the way around, how much? 720. If I go all the way around again, I have 1080. I don't think I can go all the way around again. So now at this point in time, how much more? Like, just take 1170 and subtract 1080. It's how many? 90. So I need to go another 90. So where am I going to end at? Up, down, right, left. Down. I'm going to end at the bottom. Right here. Okay? So my question is, what's my reference? 90 degrees. Does that make sense? And it doesn't matter if you went here to here or here to here. Either one is work. It's going to be 90 degrees. Back to the x-axis. Gotcha. Okay. Any other questions? How many were able to get that correct? Yes? So we can rotate in degrees and we can rotate in radians. All right. So I'm going to let you tell me at this point in time. I have two things I want to do today, and I can do different ways of doing it. Okay? So someone told me the other day, and I'm going to go ahead and stop the recording if you're absent. They can figure